Hey, what's up guys? Welcome to my YouTube channel. Hope you are all well. Today we will learn about subnet and how to find subnet in IPv4 networks. So without wasting time, let's get started. Subnet is dividing a large network into multiple small networks. It has mainly three classes. Before getting into classes, remember IPv4 is an 32-bit network architecture which is separated by 4 blocks. For example, look into this IP address which has 4 numbers in it, which means 4 blocks, and each number has 8 bits and all the bits were represented by zeros and 1, and the beginning first 3 portions is reserved for network portion and remaining portion is reserved for host portion. In class A, CADR value is 8. CADR value represents the total number of network bits and it stands for classless interdomain routing. The IP address is ranged from 1 to 126 and it has default subnet mask 255.0.0.0. As I said earlier, in this type 8 bits were reserved for network and remaining 24 bits are reserved for host. As see here, it has 4 blocks and in the first block is reserved for network as mentioned in CADR value, and all the remaining is reserved for host. In class B, CADR value is 16 and it has IP address range 128 to 191. It has default subnet mask 255.255.0.0. In this type, 16 bit is reserved for network and remaining 16 bits are reserved for host. So first we create 4 blocks and in each block we fill with 8 bits. The first 2 blocks is filled with network bits and remaining 2 blocks is filled with host bits. In class C, the CADR value is 24 and it has IP address range from 192 to 223 and default subnet mask 255.255.255.0. In this type, 24 bits are reserved for network and remaining 8 bits reserved for host. So the first 3 blocks filled with network and remaining 1 bit is reserved for host bits. Let's see how we can calculate default subnet mask. Consider this example 192.168.10.0 and its subnet mask is 24, which represent this network contain 24 bits of network. So the first 3 blocks is filled with networks and remaining 1 block is filled with host. After that, you need to calculate each network and the host blocks by writing 2 to the power of 0 to 2 to the power of 7 from left to right, and when you calculate the network 1 from left to right, 2 to the power of 0 to 2 to the power of 7, the answer you will get is 2 to 255, and when you calculate host bit from left to right, the answer you will get is 0. So the default subnet mask is 255.255.255.0 and class C has subnet mask 255.255.255.0. Let's solve one problem. Consider this problem 192.168.10.0 and subnet mask is 25. And 25 indicates total number of networks in it. When we fill first 3 blocks with the networks, we can create 24 network bits and remaining 1 network can be filled in host bit. So in host block, the first one is reserved for network. In the place of one network, we have 2 to the power of 7. When we calculate 1 into 2 to the power of 7, the answer we will get is 128 and the remaining 7 is reserved for host. So let's find the number of network we can create. The formula for that 2 to the power of 7, and in the place of n we can write total number of network bits borrowed from an host. We have borrowed only 1 network bit in the place in host, so 2 to the power of 1 is equal to 2. Let's see how to find number of IP address on each network. Formula for that is 2 to the power of n. Here n indicates total number of remaining host. The remaining host is 7 because 1 is reserved for network and the remaining 7 is reserved for host. So the answer is 2 to the power of 7 is equal to 128. Let's see how to find the number of hosts on each network. The formula for that is 2 to the power of n minus 2. Here n indicates total number of remaining host bits. The remaining host bit is 7. So 2 to the power of 7 minus 2 is equal to 126. Here we are subtract with 2 because in every network the IP address is reserved for, the first IP address is reserved for network ID and the last IP address is reserved for broadcast ID. Here we can see we can create only 2 network and in 2 network we can have 128 usable host bits. So let's in network 1 it begins with 192.168.10.0 and ends with 192.168.10.127. In this way we can have 128 host bits, but the first one is reserved for network ID and the last one is reserved for broadcast ID. So remaining 126 can be usable host network. This is what we find here. So let's create a network 2. It begins with 192.168.10.128 and ends with 192.168.10.255. First one is reserved for network ID, last one is reserved for broadcast ID, and remaining 126 host bits are usable network host bits. In this way we can solve submask in IPv4 networks. Hope this video helped you. Thank you for watching. If you like the video, please subscribe to my channel. Love you all. Bye bye. Peace.